you. First of all, thank you, SECFO, for organizing the webinar, and thank you all for your time and your interest in custodian projects. Just a moment. I cannot. No. My name is Mario Martinez, and I'm representing AIDIMME. Today, I will go deeper through the laser powder bed fusion roadmap we are following in custodian. So, sorry, I can hear some echo. Maybe you can mute your. Now it's better. Okay, thank you. So, as I was saying, I will start my presentation with a brief introduction of AIDIMME, so you can know about us. I will introduce the role we are playing here, and finally, we will address the LPBF roadmap that we are following in this project. You will see what was the starting point, what we are doing now, and what is our goal. So, okay, AIDIMME is a technology center based in Valencia, in Spain. We are about 160 employees divided in 2 buildings. And here just to show you some reference numbers of our business volume. In 2019, so we cooperated with 1,300 companies, executed more than 5,000 services, and we had about 47 ongoing projects supported by European, national, and regional entities. So our main goal is to support the companies by increasing their competitiveness in a wide range of fields. Since AIDIMME is made up of many departments, as you can see in the table on the right-hand side, with complementary expertise. So our activities focus in research and development projects, advanced technological services, as well as laboratory test analysis. We also offer technical training for companies, and in the end, we act as a technology observatory as well. So now we will focus on the department I belong to, which is the advanced manufacturing processes. From 1997, we are dealing with which is better known as 3D printing technologies, and our activities are divided into these 6 research routes, I would say. First one is the technical consultancy. So we, as you can see, we cover the full 3D printing current scenario. We have, as you can see in the top line, we can see the metal additive manufacturing we have. We have a concept laser, which is actually 100% dedicated to custodian project. We will see afterwards. We have 2 electron beam powder bed fusion, ARCAM, both of them from ARCAM, an A2 and an A2X, and 2 laser powder bed fusion from Prima Additive, which are on the way. We don't have them yet, but in the coming months, hopefully we will have these technologies. In the line below, whereas we can see the polymeric AM, we have SLA and DLP based on photopolymerization, FCC, which combines nylon with continuous fiber, and regarding the powder-based, we have SLS, selective laser sintering, and multi-jet fusion, which was the last incorporation. Regarding the second route, which is the design for additive manufacturing, we believe that this is a key factor to unlock additive manufacturing, since the way we conceive the geometries for these technologies is way too different than for traditional methods. You know, basically, the less material we put, the more optimal the AM process will be. So we try. I have shown you some examples. One of them is a development we did for the coronavirus crisis for these last months. Another working path is the technology development. As we are doing in custodian project, we also modify our technologies in order to provide them with new features, let's say. For instance, to improve the resolution, to improve the accuracy or the productivity, or we modified the technology so that we can process new materials, new non-standard materials. So talking about materials, we have developed the processing conditions for many non-standard materials. We don't develop the powder, we don't manufacture the feedstock, but we develop the whole process surround these new materials. So as you can see here, both from metal and polymeric based materials, copper alloys, nickel alloys, as the ones we're working with in custodian, titanium alloys, and so on. And last but not least, the process standardization, which is, to our minds, is mandatory when producing industrial parts. So here, basically, we make sure that process material meet the requirements of our clients so that we can provide them with high-quality parts. So now, our role, or the role we're playing in Custodian project, I will focus on the laser powder bed fusion technology. Now, as Mauricio presented before, well, basically, we add fine powder layers that are selectively melted layer by layer, creating a 3D printed part. And what we are trying to develop here, you know, in laser powder bed fusion, we work with a round shape, single shape, which melts layer by layer. And in this kind of hot cracking materials, like the nickel-based superalloys that were discussed before, we find that with the standard process working at room temperature, we obtain a high amount of cracks in the process material. So the idea is to change the shape of the laser to a shape which is to be defined yet, and in this way the aim is to reduce or to get rid of this phenomenon. So this is a scheme where I have gathered the technical work packages, which are just the same than for laser beam welding. And as you can see here, each work package is linked to the next one. Therefore, if there is a weak link in any of the work packages, it will influence the final results. So it's very important to cooperate between the different work teams in order to get good results, which is what we are trying to do. So I have highlighted in green our contributions to each work package. The work package 1, which is the definition of thermal cycle. We have tried to generate different thermal conditions while melting material with the intention to get suitable heating cycles to reduce the cracking phenomenon. I will show you some pictures afterwards. But basically, what we are trying to do is to replicate different heat treatments during the process, so that we can give a feedback to the simulation about what kind of temperatures are fine for these alloys. Regarding the simulation working pack 2, we have gathered feedback from the LPBF process, as melt pool size, what's the width and depth of the tracks, verify specific parameters and scanning strategies, so that simulation can be properly adjusted. Regarding working pack 3 and 4, which are beam tailoring and inline process control, we're cooperating to integrate those systems in our LPBF machine. It is really a challenge because the machine is closed, the software is closed, so it is really a challenge. So, and last, we are leading working pack 5, which deals with the integration and testing. So basically here we are putting all the devices developed within Custodian together, and we will check the behavior of the CM247 and the Inconel 713 low carbon with this new custom setup with this beam-shaped laser, and we will compare the results with the standard laser, with the standard round spot, let's say. So now I will go deep in the LPBF. As you can see in the images, this was the starting point. So we started from a standard concept laser M3 that nowadays is from General Electric. This machine is equipped with a 100 watt laser, or was equipped with a 100 watt laser. And well, just to remark that with the configuration of the standard machine, we just could modify some specific parameters, a few parameters, like the scanning speed, laser power, line offset, and some other parameters that we normally manage in these technologies. So the challenge was that in this standard machine, we will implement, on the one hand, a shaping unit, which will require much more energy than 100 watts. So it means that we have to implement or to integrate a high power laser and a scanning head according to this laser. So in addition, we will also include this closed control loop. So we have to ensure that in the end, all these devices have full compatibility between the LPBF machine and all the components, the shaping unit, laser, the high power laser, and the closed control loop equipment. So this is the current status today. So what we have is a modified laser powder bed fusion machine with a high power laser installed and fully operative. The M-wheel camera was successfully installed, and we can get, as you could see, as you were able to see in the presentation from Roberto and Germán from NIT, we can get closed images from the melt pool, and well, due to all those modifications, we also put a lot of efforts in the security protocols of the machines, because we started with 100 watt laser. Now we have about a 4 kilowatt laser inside the machine, so many things have changed. We have focused our efforts in the security protocols, in many adaptations of the machine and the chamber, and we have included some thermal sensors and heating device in order to carry out these heating experiments that I will show now. So this is how the machine looks like now. Just want to remark that all the experiments that we have carried out so far have been done with the high power laser, because basically it's the laser source that we will work with till the end of the project. And what is interesting here is that after changing the laser source, we have to manage different things from the software and rewire many things of the standard machine. Now we are able to adjust or to modify many more parameters and strategies and scanning strategies than before, which is interesting for the project because we can control much more things than before. And in phase 2, the project is much better with the scanning, with the setup that we have now. Here's some images of the induction heating device that was implemented in order to replicate specific thermal conditions. So the idea, you can see, this is the carriage of the laser powder bed fusion technology. We basically installed an induction heating device so that we can preheat and postheat the start plate or even the part that we are building. So that the idea of these experiments was to get information about what kind of temperatures are suitable for these crack tendency alloys. So for the time being, we have been working with this heating device and with the high power laser in an iterative process to obtain what we normally call the processing window, which basically is the ideal setup of parameters or conditions where these alloys can be processed. So next steps will be the integration of the beam shaping unit and testing. So hopefully with this ideal shape that is being defined now, what we pretend is to get rid or to reduce this cracking phenomenon. So this is an image of CM247, sorry, there's a mistake here, processed with the current LPBF setup with a high power laser. And that's all from my side. If you have any question, I'm happy to answer you.